I want to get started with my talk today. I'll be talking about some of the fundamental blocks of technology and about a topic that is of great interest today, that is the Internet of Things. And ultimately, what I want to share with you is that there's some very simple, powerful ideas. Sometimes we get lost in all the jargon, but at the core of it, what we're trying to do is something quite simple. And so I encourage you to think of that in terms of these patterns, these fundamental models that can change or transform our society. And so one of them that has this potential is certainly the Internet of Things. The fundamental idea is simply this connection between the physical and the virtual. Tim Berners-Lee, the web, connected documents globally. You now have an index of over 1 trillion documents, and we've talked about the impact of that. This is going one more step and connecting onto the physical world. And we'll discuss the impact. Now, as we move into the second generation, as this idea, fundamental idea, starts to be adopted by many other industries, I wanted to share with you some observations of some other industries and where this is taking place. This is a picture of a farm that is 5 minutes from my house. It is run entirely by women. It is so popular that you actually have to enter a lottery for your right to be able to purchase vegetables from them. Very successful, very well supported by the community. You can go there and you can see the wonderful work that they do and harvest and pick up your vegetables every week. However, farming looks very different today. This is a picture of a tractor, a smart tractor. Take a look at all of the instrumentation that it has. It divides the planting area, the field, into something akin to a jigsaw puzzle, where it plants the optimal amounts of seeds. It has an overseed or underseed, and every single region of your field has a different type of tolerance. The difference between being wiped out and having a successful harvest is 1 inch in depth. So all of this information, all of that intelligence is started to be collected to better understand what makes a farm successful. How do you grow crops in a better way? Weather modeling and a number of other technologies that have been used in other domains are coming to farming. And in fact, you already read headlines of the big race for agriculture data. Another one is that of football. You know, typically you think of American football as a big, giant, beefy guys that if you have a lot of them, you could do very well on the field. But the same type of instrumentation is coming to this field. Of course, players don't have little antennas, but they have an RFID chip in the shoulder pad, and all of the stadiums for the National Football League are being instrumented to collect that information and make it part of the team analytics. So I want to make the point here that this is not something that couldn't have been collected before. You can imagine you can have a team of people figuring out the yardage and the position in the field, and you can start to collect this information. But think of the effort that it would take. Again, referencing the ease of use, the increased access to information. People say often in the business world that at every order of magnitude of improved access to information, you have a new generation of startups. This is representative in the Internet of Things. We have a recent graduate that did his master's thesis on trying to quantify the decision-making ability of a quarterback. Using this technology and using this data, he was able to quantify what players were open and was able to analyze this in near real time. If you think about what happens from the time the quarterback gets the ball, steps back, and releases, it's about 3 seconds. In those 3 seconds, 22 players are moving. Each of them have different rules and have complex patterns that they move to. Parsing that visually or with a team is actually quite tough to do. Using these technologies, you can now do it real time. So you can imagine the impact that this will have for decision making in the field. Now, I'm told that in the Philippines, basketball is very popular. So I'll quiz you. Who is this player? Yeah, Ray Allen, right? I'll ask you, what was his shooting percentage? It was very good, right? It was actually over 40% by the time he retired. Who's broken that record now? Yeah, that's right. And I think we'll all agree that Curry is not normal, right? Obviously, Ray Allen was someone that if you were the opposing coach and he went up for a three-point shot, you say, oh no, here it comes again, right? He was deadly, he was accurate. There was many a game where you saw him in the last 3 seconds spotting up for the corner, hitting the game-winning shot. However, if you collect all of that information from Ray Allen and you start to represent this geospatially, you'd be able to see a graph such as this. And that gives you a very different understanding of Ray Allen. In fact, if you look on the lower left-hand corner from the college three-point line, not the NBA three-point line, you'll see that he's actually quite poor, right? So that's counterintuitive. You wouldn't think that a shooter of that talent, if you push them in 3 feet, would be poor, but he turns out to be. Also, from the perimeter, from the three-point shot, you'll see that he is more effective in some parts than others. Now, this paper was presented at MIT at the Sloan Sports Analytics Conference, and it took about a year of collecting data, of doing analysis, of trying different types of visualizations. So obviously, this was very slow. However, imagine that you put an antenna on Ray Allen, and you start to make this graph real time. And as you might imagine, this is what's already being attempted. It's being done with a different technology as opposed to RFID. It's being done with cameras and figuring out the geometry. But that type of data insight is what the sports teams are going after. And if you look at sports in general, now at MIT, you have the professional sports leagues looking for data scientists to go into sports analytics. This is a picture of the Pope's election in 2005. I'm going to show you the next one in 2013, and there's a slight difference. You can see there how our world is started to be instrumented. Each of these smartphones carries more than 20 sensors, and that's already participating. It's not just individuals, it's also the industrial side as well. The projections, depending on who you look at, range anywhere from 50 to 100 billion of these. Imagine the amount of data that is going to be generated and the intelligence that can be derived, but they're going to be big regardless. The next challenge that comes, of course, is how are you going to orchestrate these? And there's a number of platforms that are open in the market, meaning it doesn't matter which vendor you come from, into which you can integrate your Internet of Things devices. One of the most popular ones at the outset was if this, then that. You can see here lights, you can see tablets, you can see watches, and you can imagine that there's a number of workflows of activities and interaction with physical devices that you may want to do. And so what I have here is a demonstration of a couple of lights that I connected to my home network, and I'm using here 3 different things. I'm using the Philips network, I'm using my own home network, I'm using if this, then that. I'm actually using as well a tablet. One of the things that I wanted to comment on this is that if you go get one of these low-cost pieces of hardware, say a Raspberry Pi, and you connect it to your computer and you download the editor and then you look for a light bulb and you connect it to this board, the amount of time that it will take you to figure that out, even if you are a computer science student, will be at least a day. So certainly the access to this type of functionality is limited to those that have high skills. However, in these new platforms that are appearing, it took me 5 minutes to connect all of this hardware and get it going. So that type of functionality, that type of ease, collecting the data that's coming off of it, all of that is being simplified. The level of abstractions are going up, and the ability to build on those building blocks is now simpler. You can see here some of the recipes that are available within that site. You can see there for when your car shows up in the upper right-hand corner, turn on your lights at home. You could see similar things. Say, for example, if you're within a mile of your house, turn on your air conditioning. And these type of applications. There's many others that you can write. So this is simply representative of many other sites that are appearing. This one is called Build.io, is reaching into other domains as well. You can see here travel and others. Microsoft recently started a site that's called Work Less, Do More. It's called Flow, and it's in preview, but it's a similar idea. So all of these together, all of these services, all of this functionality, all of these platforms onto which you can put on IoT devices are being offered to us as a new set of building blocks, new set of services, of resources that we can use to leverage and build something new. If we think about Uber, Uber did not start from scratch. Uber used Google Maps. It didn't have to write a mapping application. When it came to texting, Uber used Twilio. It didn't have to write a texting application. When it came to voice, similar thing. And as you go down the road, you can see that it coupled all of these services and provided a new offering to the market that is taking over the world. So for you that are starting out, these teams can be quite powerful. And if you understand the building blocks that are available to you, you can create powerful new services and products that can create a new offering in the market. Within academia, we're doing something similar. We're trying to surface and offer to the community not just our content, but also our code so that it can be repurposed, put together to answer new research questions. We're doing that principally in the domain of decision support. All of this, as I mentioned, can be used to better understand our environment and use our resources. So I want to close by simply making a comment on the autonomous vehicle. Car companies are quickly rebranding themselves as mobility companies because they worry that the car will become simply the hardware through which additional services are provided. Think of the early PC companies. In the early days of the web, they were huge. They were the biggest ones in the market. All of them have struggled, and you can see their market share decrease as the years have gone by. The car companies don't want to be in that scenario where you're simply buying hardware from them, everything else comes from a different vendor. So if we think about an always connected vehicle that has location, I'll pose to you, would you be willing to share that car? Remember, this is an autonomous vehicle. Raise your hand if you say yes. I have 2, 3, 4. So obviously you don't want to. What if you could get paid? Raise your hands if you would share if you got paid. Yeah, everybody would like that, right? Now imagine you can start to make money, right? What if you could also have your car start to service itself, use some of that revenue? What if you could start to create smart contracts? Remember the blockchain technology. And you could start to participate in these transactions, all of it without being an additional burden of you. I've experienced the traffic of the Philippines. I think nobody wants to go to a gas station, right? Because it's just such a bear of a fight. And you can imagine there also additional intelligence. We live in a very suboptimal world where we consume simply when we need. Most of the patterns of the population follow a certain schedule, right? We all sort of consume energy at a certain time during the day. What if we could program this to consume when it was cheapest? We would certainly get an efficiency there. Likewise with maintenance, car washing, and you can imagine that this new car or this new car of the future, autonomous vehicle, may become the next platform or the next device onto where applications are being delivered. There are 1.2 billion cars roughly in the world. If you're no longer driving, this would become an environment for productivity, for entertainment, for additional services that could be delivered. You can imagine there will be a new wave of startup companies that will offer services in this regard. Obviously, there would be some type of ecosystem of applications. There would be some type of data collection. You can imagine how this might start to lead to efficiencies. What if your car could tell when it was going to break down months in advance based on the patterns of similar vehicles out in the traffic system, right? And so it could drive itself over to the mechanic. It could use some of the revenue that you've collected, get itself fixed up. And you can see that owning a car, the cost of it will certainly diminish, but also the richness of services that you could receive through it would be pretty different. And so it would be a much smarter environment. Now, this is what the Philippines traffic looks like. It's certainly no fun. But think about this number. In the US, 95% of the time of a car, it's spent simply being parked. Think about the potential there for efficiency, where you have visibility, much like we said about the football players, where you have visibility directly into where that vehicle is. Imagine simply walking out into the street and being able to use anybody's car. You could trade off with somebody else's. So there's a tremendous amount of flexibility. There's a tremendous amount of efficiency that could be done. You could certainly impact traffic even if you convinced only 15% to join, you would reduce the number of cars on the road significantly. Now, of course, it's not just cars. Our understanding of our resources and our consumption within cities, our traffic patterns, our energy consumption. Think of all the physical infrastructure that we use, and our government's ability to understand what will work is very poor. As this information starts to be leveraged, starts to be integrated into government planning, a better utilization of resources will be made. Certainly, when plans are made, for example, one of the projects that I have is trying to decide on desalination technologies in the Middle East and countries, and these type of reports are usually 2,000 pages long, take 3 years to do, and are delivered to the government in a stack. We're working on creating a real-time decision system where you could try different technologies, you could try different types of routing of power or routing of water, and you could model population growth, and you can see that there's a very different way in which you can make decisions. This type of decision-making based on Internet of Things devices in the world is the future, and it certainly has tremendous potential. The same thing could be true for a nation and obviously the world. So with that, I'll simply close by saying there is a new generation of technology here leveraging that simple idea of simply adding location information and making that connection between the physical and the virtual. There's a number of technologies that is building on that are now quite mature and readily available to everyone. So with that, I'll thank you for your attention and close.